Based on the provided information, the underground raceway for the polyvinyl chloride, or PVC, conduit installed to serve floor outlets in the patient care area of a dentist office should be installed in a metal raceway system. The National Electrical Code, or NEC, Section 517.13, -2005 mandates that all branch circuits serving patient care areas be provided with a ground path for fault current achieved through installation in a metal raceway system. This requirement is crucial for ensuring proper grounding and safety within these sensitive areas. The purpose of requiring a metal raceway is to provide a low-impedance ground fault current path. In the event of a fault, such as a short circuit where a live conductor comes into contact with a grounded surface, a metal raceway provides a dedicated path for the fault current to flow back to the source. This high current flow causes the overcurrent protective device, such as a circuit breaker or fuse, to trip quickly, energizing the circuit and minimizing the risk of electrical shock or fire. PVC conduit, being a non-conductive material, does not provide a ground fault current path. While it offers excellent protection for conductors against physical damage and environmental factors, it cannot facilitate the rapid clearing of ground faults. Therefore, relying solely on PVC conduit in patient care areas would violate the NEC requirements and compromise electrical safety. The transition from PVC conduit to a metal raceway system typically occurs at the point where the conduit enters the patient care area or connects to the floor outlets. Various methods can be used to achieve this transition, including the use of appropriate fittings and connectors that ensure a continuous and reliable electrical connection between the PVC conduit and the metal raceway. Acceptable metal raceway types include, but are not limited to, electrical metallic tubing, or EMT, rigid metal conduit, or RMC, and intermediate metal conduit, or AMC. The choice of raceway type depends on factors such as the specific installation environment, the degree of physical protection required, and local code requirements. It is essential to select a metal raceway system that is properly sized and installed in accordance with the NEC and other applicable standards. The metal raceway must be effectively grounded to the building's grounding electrode system to provide a low impedance path for fault current. This grounding connection should be made using appropriate grounding conductors and connectors, ensuring a secure and reliable electrical connection. In addition to the metal raceway requirement, other grounding and bonding requirements apply to patient care areas. These requirements are designed to minimize the risk of electrical shock and ensure the safe and reliable operation of electrical equipment. Some examples of these requirements include the use of isolated ground receptacles, supplementary equipotential bonding, and regular testing of grounding systems. Isolated ground receptacles are designed to minimize electrical noise and interference, which can be particularly important in sensitive medical equipment. Supplementary equipotential bonding involves connecting all exposed metal surfaces in the patient care area to a common ground point, further reducing the risk of voltage differences and electrical shock. Regular testing of grounding systems is essential to ensure that they are functioning properly and that all grounding connections are secure and reliable. Failure to comply with the NEC requirements for grounding and bonding in patient care areas can have serious consequences, including electrical shock, fire, and equipment malfunction. Therefore, it is crucial to consult with a qualified electrical engineer or electrician to ensure that all electrical installations in patient care areas are designed and installed in accordance with the applicable codes and standards. Several factors should be considered when selecting a metal raceway system for patient care areas. Firstly, the raceway must be listed and labeled for its intended use. This ensures that the raceway has been tested and certified to meet applicable safety standards. Secondly, the raceway must be sized appropriately for the number and size of conductors it will contain. The NEC provides guidelines for determining the maximum number of conductors that can be installed in a given size of raceway. Thirdly, the raceway must be installed in accordance with the manufacturer's instructions and all applicable codes and standards. This includes proper support, secure connections, and appropriate grounding and bonding. Furthermore, the selection of fittings and connectors is crucial for ensuring a reliable and safe electrical installation. Fittings and connectors must be listed and labeled for use with the specific type of raceway being installed. They must also be properly sized and installed to provide a secure and watertight connection. In addition to the metal raceway requirement, the NEC also specifies requirements for the type and size of grounding conductors used in patient care areas. Grounding conductors must be made of copper or other approved material and must be sized in accordance with the NEC tables. The grounding conductor must be connected to the metal raceway and to the grounding terminals of all receptacles and equipment served by the branch circuit. The NEC also requires that all metal enclosures and equipment in patient care areas be bonded together to create an equipotential grounding system. This bonding helps to minimize voltage differences between different metal surfaces, reducing the risk of electrical shock. The bonding conductors must be sized in accordance with the NEC tables and must be connected to all metal enclosures and equipment using approved bonding methods. Regular inspections and testing of electrical systems in patient care areas are essential for ensuring continued safety and compliance with the NEC. Inspections should be performed by qualified electrical inspectors who are familiar with the specific requirements for patient care areas. Testing should include verification of grounding and bonding connections, insulation resistance testing, and ground fault loop impedance testing. Any deficiencies identified during inspections or testing should be corrected promptly to ensure the safety of patients and staff. In addition to the NEC, other codes and standards may apply to electrical installations in patient care areas. These may include local building codes, healthcare facility standards, and equipment manufacturers' recommendations. It is important to consult with all applicable codes and standards to ensure that the electrical installation meets all requirements. Proper documentation of electrical installations in patient care areas is also essential. Documentation should include wiring diagrams, panel schedules, equipment specifications, and inspection and testing reports. This documentation can be used to facilitate maintenance, troubleshooting, and future modifications to the electrical system. The NEC provides specific requirements for the labeling of electrical equipment in patient care areas. Equipment must be labeled with its voltage, amperage, and other relevant information. Labeling helps to ensure that equipment is used properly and that maintenance personnel can identify equipment quickly and easily. In summary, the requirement for metal raceways in patient care areas is a critical safety measure designed to protect patients and staff from electrical hazards. By providing a low-impedance ground fault current path, metal raceways help to ensure that overcurrent protective devices will trip quickly in the event of a fault, minimizing the risk of electrical shock and fire. Compliance with the NEC and other applicable codes and standards is essential for ensuring the safety and reliability of electrical systems in patient care areas. Always consult with a qualified electrical engineer or electrician to ensure that all electrical installations are designed and installed in accordance with the applicable requirements. The information provided is based on NEC Article 517.13. -2005 and General Electrical Safety Principles. The NEC is updated regularly, and it is important to consult the latest edition of the code for the most current requirements. Additionally, local codes and regulations may impose additional requirements that must be followed. Therefore, this information should be used as a guide and not as a substitute for professional electrical engineering or electrical contracting services. The grounding electrode system is the means by which electrical systems are connected to the earth. This connection provides a low impedance path for fault currents to return to the source, helping to ensure that overcurrent protective devices operate quickly and effectively. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes, that are connected to the electrical system through a grounding electrode conductor. The grounding electrode conductor must be sized in accordance with the NEC and must be securely connected to the grounding electrode into the electrical system's grounding busbar. The size of the grounding electrode conductor is based on the size of the service entrance conductors. The larger the service entrance conductors, the larger the grounding electrode conductor must be. In addition to the grounding electrode conductor, the NEC also requires that all metal enclosures and equipment be bonded together to create an equipotential grounding system. This bonding helps to minimize voltage differences between different metal surfaces, reducing the risk of electrical shock. The bonding conductors must be sized in accordance with the NEC tables and must be connected to all metal enclosures and equipment using approved bonding methods. Approved bonding methods include the use of bonding jumpers, bonding bushings, and other listed bonding devices. Bonding jumpers are short lengths of conductor that are used to connect two or more metal enclosures or equipment together. Bonding bushings are used to connect metal conduit to metal enclosures, providing a low impedance path for fault currents. Other listed bonding devices are available for specific applications and should be installed in accordance with the manufacturer's instructions. Regular inspection and testing of grounding and bonding systems are essential for ensuring their continued effectiveness. Inspection should be performed by qualified electrical inspectors who are familiar with the specific requirements for grounding and bonding systems. Testing should include verification of grounding electrode resistance, bonding conductor continuity, and ground fault loop impedance. Any deficiencies identified during inspections or testing should be corrected promptly to ensure the safety of patients and staff. Proper grounding and bonding are essential for electrical safety in all types of facilities, but they are especially important in patient care areas. In these areas, patients may be more vulnerable to electrical shock due to their medical conditions or the presence of medical equipment. Therefore, it is crucial to ensure that all electrical systems in patient care areas are designed, installed, and maintained in accordance with the NEC and other applicable codes and standards. The NEC provides detailed requirements for grounding and bonding in patient care areas, including requirements for isolated power systems, ground fault circuit interrupters, and equipotential grounding. Isolated power systems are used in some critical care areas to provide a higher level of electrical safety. These systems isolate the electrical power supply from ground, reducing the risk of electrical shock in the event of a fault. Ground fault circuit interrupters, or GFCIs, are used to protect against electrical shock by detecting small leakage currents and interrupting the circuit. GFCIs are required in certain locations in patient care areas, such as bathrooms and wet locations. Equipotential grounding involves connecting all exposed metal surfaces in the patient care area to a common ground point, further reducing the risk of voltage differences and electrical shock. This equipotential grounding system must be designed and installed in accordance with the NEC requirements.